This gathering is a demonstration of the commitment of the federal government led by His Excellency, President Bola Ahmed Tinubu, through the Renewed Hope Agenda to adopt innovative, climate-smart, and future-oriented energy solutions. The feasibility study being launched today is not only a technical exercise, it is a strategic milestone on the path to modernizing and future-proofing Nigeria's power infrastructure. It is a well-known fact that Nigeria's power sector has undergone significant reforms. Nonetheless, certain challenges persist. These include the intermittency, limited dispatchability of renewables, grid instability, and underutilized generation capacity. In the expectation of the increasing penetration of renewable energy into our energy mix, as envisioned by the Nigeria Electricity Vision 30-30-30, it is imperative to provide for energy storage facilities to capture surplus electricity when supply exceeds demand and to dispatch it reliably when needed. Ladies and gentlemen, battery energy storage systems, BESS, offer the practical and scalable solution. Their deployment in the national grid will play a vital role in 1, enhancing grid stability and operational flexibility. 2, reducing reliance on fossil fuel-based peaking plants. 3, enabling deeper integration of renewable energy across grid-connected and off-grid applications. 4, improving power quality during voltage and frequency disturbances. And 5, expanding access to clean energy for underserved and remote communities. Notably, the grid-forming capabilities of advanced battery storage systems set them apart. Unlike traditional grid-following inverters, grid-forming bays can establish voltage frequency references, acting as virtual generators. This makes them invaluable in supporting grid frequency regulation, black start capabilities, and system resilience during outages. Bays do not only store energy, they reinforce grid stability. This feasibility study will deliver a comprehensive technical, regulatory, financial, and environmental analysis of battery energy storage deployment across Nigeria. Specifically, it will identify priority locations nationwide for BESS installations, recommend viable business models and financing structures, propose enabling policy frameworks to attract private sector investment, and outlined actionable implementation pathways aligned with our national energy transition goals. The study will also examine how BESS can complement reforms under the Electricity Act 2023, which empowers the subnational authorities and encourages decentralized energy development. The federal government remains steadfast in its commitment to the Nigeria Energy Transition Plan, ETP, which charts our course to net zero emissions by 2060, while expanding energy access and driving sustainable industrialization. This initiative aligns with the global efforts to combat climate change, support just energy transitions, and achieve the targets of the Paris Agreement and Sustainable Development Goal 7, ensuring access to affordable, reliable, sustainable, and modern energy for all. Battery storage is not only a variable tool for enhancing grid reliability, but also for economic development, job creation, and climate resilience.
On behalf of the Transmission Company of Nigeria, I'm pleased to welcome you to this inaugural workshop for the Nigerian Battery Energy Storage Systems Feasibility Study. This gathering marks an important milestone in the energy sector in Nigeria. Today, we bring together the diverse expertise of government institutions, regulators, development partners, and private actors to focus on our collective effort on a project with far-reaching implications for the stability and future of Nigeria's power grid. At TCN, our mandate centers on maintaining and expanding a transmission network that is reliable, resilient, and able to respond effectively to the demand of our growing economy. For years, our operational teams have contended with the challenges of frequency fluctuations, peak load pressure, and limitation in reactive power support. These technical constraints have felt at every layer of the electricity value chain, from generation dispatch to the final delivery of power to homes and industry. Battery energy storage systems offer us a powerful means to address these persistent challenges. For example, they enable frequency regulation, reserve capacity, and voltage support, directly strengthening grid performance and unlocking more efficient use of our transmission assets. This is precisely why this feasibility study is both timely and so important. This workshop is an opportunity not only to understand the technical and commercial dimension of BESS, but also to determine the institutional readiness, operational protocol, and capacity building priority that will underpin successful implementation. From grid code and safety standard to workshop training and asset management framework, we must ensure that our planning today is comprehensive and forward-looking.
Energy storage feasibility study, which is what we are discussing today, is a key piece of Nigerian energy transition puzzle. Of course, the importance of this initiative cannot be overstated, and as we work towards the ambitious goal of the M300 of trying to connect 300 million Nigerians, battery energy storage becomes a very critical and important aspect of achieving this aim. And nowhere in this mission that this is more urgent than Nigeria, where it has been estimated that well over 90 million people are without electricity access. It may interest all of us here to know that Africa holds almost 60% of the world's best solar size and resources, but yet accounts for only 2% of global energy storage. This shouldn't be. The gap presents a challenge, but more importantly, an opportunity. Battery storage is central to unlocking the full potential of our renewable energy resources, delivering stable and reliable power across the continent, and even stabilizing our very, very important power grid. We're already seeing inspiring progress, and the bank has recorded some of them. In South Africa, 1,400 megawatt-hour battery storage project is supporting the grid stability and solar integration. In Kenya, the Okaria geothermal battery hybrid is delivering reliable energy to millions. Now is the time for Nigeria, and we appreciate TCN giving us this opportunity to collaborate with them, and we want to say thank you very much.
I'm going to take up this section to unlock the potential of battery storage system in Africa.
Basically, in the area of congestion, I think that's where BESS will do much of the work required. How? Where there are congestion areas, we can deploy BESS in that location. And this will solve some of these problems as you rightly placed there. The issue of voltage, the issue of load loss, and as well, the area of finance will be improved, because where you have losses, there you will lose a lot of money. So with BESS being deployed in those nodes, depending on the region, because transmission side we have 10 regions. So planning, yes, is still being carried out to know is that area where this BESS should be effectively and optimally deployed. And with that, we will reduce some of these losses and as well reduce the issue of infrastructure development, because to operate a particular transmission line costs much.
With BESS, this will actually help to stabilize the system. And our main role as an enforcement agency is, that's the critical role, is reliability, safety, because in anything we are doing, we need to take safety as priority. So safety to deliver in line with standard and regulation. So we are there to inspect, test, and certify that BESS can be integrated into our grid, because we need to do an holistic inspection, testing, and certifying the project before it can be connected to grid.
So for rural places, we know that they are very far from the grid. There have been a lot of mini-grid interventions, but projects work for a few years and then collapse. They collapse because sometimes if they're not properly designed, and the most critical failure point for what I've seen in most mini-grid is the battery energy storage. That is the weakest link. And the battery looks simple, but it's not simple, because the technology, the operation, the weather, these are things that affect it. So in a rural environment where you don't have access to the grid to charge it correctly and completely, you need to get your charging cycle correct. So if we don't want to keep wasting money as a country, it means for rural projects, we need to pay attention to that aspect that has to do with battery, and then look at the current technology. If they do not serve us, we need to do away with them, and then bring some of the best technology in base that can serve in those places.